Welcome back, guys. Today I want to answer the most common question that I get when people see my welds, and that is,
Dude, what are your settings?
so today we're going to go over what I would recommend for settings for your three most common materials that you're going to be TIG welding. That would be aluminum, mild steel, and or stainless. Today we're going to be using our Primeweld TIG 225. Now these settings will directly apply to most any other newer inverter welders. The knobs and buttons might be slightly different, but the general principles will apply. So let's get started. But before we get started with that, I want to be able to bring you guys the most value, and I'm going to make a little assumption here. And the question of what are your settings, I'm going to assume that your intention behind that question is to be able to maximize your own skill and learn how to be able to make a good, clean weld. But stepping back from that, I want to kind of ask you a question. Now, that question being very valid and important, making a good, clean weld, there are lots of different things that go into it, and I feel like your settings are a very minute part of that. So I kind of want to ask you a quick question. So I'm going to say metaphorically, this morning, I walked up to you this morning when we got to work, and I was like, man, I seen you driving on the way to work this morning. You were just making a straight run down the road. It was a beautiful pass, looked great, looked like with great skill and quality. What were your settings? And you'd look at me kind of funny, like, what the heck are you talking about? And I'm like, yeah, well, like, what was the camber in your front end set at? And, like, what was your tire pressure set at? And maybe what was the volume of your radio set at? And you might look at me kind of funny. Same thing with welding. Although your settings are very critical and do play a key part, the primary thing that allowed you to drive straight down the road is experience and seat time. Being able to get that time in, learning cause and effect, learning that if there's a bump in the road, you know how to turn out of the way or compensate it with more pedal or less pedal or vice versa. Your settings are important. It is going to affect the way that it runs, but getting that seat time and learning those cause and effects, maybe having a mentor there to show you, hey, when you do this, this happens. Or if you don't have a mentor there, stepping back and looking at your own welds and trying to break down what you actually did. So the other things that play, I believe, a higher role in making a good weld are your feed rate and your travel speed and regulating your pedal depending on how far you are into the weld. Because when you start off, your ambient material is going to be cooler, so you're going to need more amperage. But as you continue on and progressively, you're going to need to back out of that pedal because the material itself is heating up, so therefore you do not need to put as much amperage into it to be able to heat that material up and maintain that temperature to carry out a quality weld. So that's my little rant there. Hopefully that makes sense, and hopefully that was of value. Let me know in the comments, and let's get started with our settings. Okay, let's get started with our settings here. So I'm not going to go over any of the pulse features or anything like that. I'm just going to show you the standard run-of-the-mill settings that you're going to need to get started with this. And to start off with, we are going to start with the settings that you would use for either mild steel and or stainless steels. So now when we look at the front of our machine here, this can be kind of intimidating. There's lots of knobs and buttons and stuff, but we're going to simplify this for you. So okay, hopefully this looks a little less intimidating. We only have 3 knobs and 4 switches that we want to deal with. And we want to remember that this is for mild steel and stainless steel. Now, the first thing that you're going to want to do on your Primeweld is you want to make sure that you are in the TIG functions. We want that switch switched up. We are going to want to run in DC. So switch this guy down to DC. This is assuming that you're going to be running a pedal. So if you're running your pedal, you want to flip this switch over here to the T2 function. We have our amperage, our pre-flow, and our post-flow. Now there are multiple different opinions on this. I'm just going to show you what I would recommend, and you can do your due diligence. So on pre-flow, it's going to be a little more critical to have some more volume on stainless, but I recommend if you're practicing to keep that down pretty low just to conserve gas. Now your amperage. When you turn this guy, it will show on the digital readout here. For amperage, we want to use our general rule of thumb. So the general rule of thumb is 1 amp per thousandth of an inch. So if you're running 1/8 inch material, or roughly 3 millimeters, I believe, 1/8 inch material is 125 thousandths. So by the rule of thumb, you would want to set your amperage to 125. Now, I actually like to use that rule of thumb and then up it by 50 amps. So if it's 125 thousandths, I'm going to up it to 175 thousandths. And that is just so I have a larger range. If I need that heat, I can compensate for it and it's there. Now, I'll put a video up here kind of explaining why I like to do that and why I feel it's important, especially to keep your heat signatures down. Yes, turning your amperage up can keep your heat signatures down, and this little video will explain that. And the final knob is your post flow. I recommend keeping your post flow if you're practicing somewhere in between 5 and 10 seconds. And yeah, it's as simple as that for our mild steel and stainless. That is the only settings that you're gonna need. The rest of it is gonna be seat time. So get in the seat there and get some practice done. Now we're gonna go over our aluminum settings. Now, once again, I'm going to simplify all this busyness for you so it's a little less overwhelming for our aluminum settings, and we're gonna do that again. And here we are. These are the only things that are gonna be different on your aluminum. We added 2 extra knobs to the mix here. So the only changes, your amperage is going, or weld current is going to be the same rule of thumb. Pre-flow can stay the same, post-flow can stay the same. We're not doing pulse features. We're staying on T2. We're switching this from DC to AC. And then we have our 2 new knobs here. The short answer is 80% of whatever I do, I'm gonna have my AC frequency somewhere in between 120 and 140 hertz. And my AC balance in between 30 and 40%. Now, that's the short answer to the aluminum settings. If you want to stick around for just a second, I will explain to you a little more in depth on why that's the case and what you can do to change them depending on your situation. So we got the markers out here and got something drawn up, and hopefully we can make this easy to understand. So with aluminum, we're going to be using AC current, like I mentioned. So with AC current, you have an upslope and a downslope. Your upslope is going to be positive and your downslope is going to be negative. So just like when you're running your steel, you're going to be on DC negative. With DC negative, your current is going to be running from the negative side of the port, which your torch should be plugged into, down through your electrode and into your workpiece or your substrate. When you are on DC positive, I don't know if you've ever had a transformer welder, an old transformer welder, where you had to stick it on DC positive to ball up your tungsten to be able to weld aluminum. Thankfully, we don't have to do this with these machines. On DC positive flows from the table, from the positive side, up into your electrode. So that's why you get that hot balling effect, and that's why we use AC current, because aluminum, we have 2 separate melting points. We have our oxide layer and our substrate. So if you went to try to just weld this with DC negative, just like you would your mild steel, you would penetrate through and melt your base layer, but you wouldn't have enough heat to melt that oxide layer on the surface, and you just have this kind of molten yucky stuff sitting on the top. And vice versa, if you just had it set on DC positive and the positive polarity, that amperage would be coming off the surface of your workpiece, and that current would be trying to get up into your tungsten and balling up your tungsten, and you would be getting 0 penetration into your material and just making a mess. So this is why it's important to have our alternating current. They both serve a good purpose. So we're going to start with our balance knob, and it is set out in percentages. The percentage is the percentage of the wavelength in time, meaning if you have your AC balance set to 50%, 50% of the time you're going to be on the upslope cleaning, and 50% of the time you're going to be on the downslope penetrating. Now if you have your knob set to 30%, 30% of the time you are going to have your upslope cleaning, and 30% of the time you are going to be penetrating, and 70% of the time that slope will be penetrating. The importance to this, if all possible, you want to get the most penetration out of your weld, and that's why I recommend running your balance somewhere in between 30 and 40%, but also because that is very important to clean your material. Get a good Scotch-Brite and break off most of that oxide layer so that you can run less percentage on your positive side and more percentage on your negative side and get a better, stronger penetrative weld. Now, that being said, maybe you are going to be welding some cast aluminum, and that's where you might want to be more a 50-50 balance. So you have some more time, you can generate some more heat to burn out those impurities, and then that other percent of that time you're penetrating and making that weld stick together. So that is what your AC balance knob is going to be doing. Your other knob that we added on was the hertz. Now the hertz is how many times this wave happens in 1 second. Now 1 hertz would be 1 positive and 1 negative wave happening in 1 second. But I recommend you run upwards in the 120 to 140 hertz range. And there's a reason for that. So if you're running down on 50 hertz, you are going to have 50 of these cycles per second. And this is going to be a little bit slower, so it's going to give you a wider arc. Somewhere in between 120 and 140 hertz is going to narrow that arc up and give you good control over that arc and help that puddle to flow along. Now this machine has the ability to go up to 200 hertz per second, and this will serve you well on thinner material when you need to really focus that arc and get it down tight. But in most cases, I'm going to recommend you sticking between the 120 to 150, 140 range. That's going to be your best overall multi-purpose. 90% of the time, that's where I'm sitting at. So hopefully this was helpful. Hopefully it was easy to understand. Let me know in the comments if it wasn't. Let me know if it was. Be much appreciated. So thanks for watching, guys. Make sure to hit that bell icon and subscribe. We will be definitely making some more videos with our Primeweld here and other fabrication products. So subscribe, like, and go build something.